My dear students, welcome back to our channel. In this video, I will be explaining the MCA second semester subject Operating Systems as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 4 first important short question is: define system protection in operating systems. System protection in an operating system, OS, means keeping computer resources safe from unauthorized or harmful use. These resources include the CPU, memory, files, and input-output devices. The OS ensures that only authorized users or programs can access them. Think of it like a security guard in a building. Only people with the right ID cards can enter certain rooms. Similarly, the OS checks permissions before allowing access to files or resources. How it works? 1. User authentication. Only verified users can log in. 2. Access control. Permissions, read, write, execute, are set for files. 3. Memory protection. Prevents one program from using another program's memory. 4. Hardware protection. Blocks unauthorized access to CPU or devices. Example: in a multi-user system, your friend cannot delete your assignment file because the OS has given you write permission but only read permission to others. Easy tip: think of system protection is equal to digital security guard protecting your computer's resources. Next important long question is: 2. Define access control and access rights in operating systems. Access control and access rights in operating systems. Access control in an OS is like a security gate that decides who can use what on a computer. It ensures that only authorized users or programs can access files, memory, devices, or data. This prevents misuse and keeps the system secure. Access rights are the permissions given to a user or program. These define what action can be done, such as: read, R, view a file. Write, W, modify or delete a file. Execute, X. Run a program. Example: in your college computer lab, teachers have read-write access to exam papers. Students only have read access to view them. The OS enforces these rules like a digital watchman. Quick tip to remember: access control is equal to the gatekeeper. Access rights is equal to keys given to users. Together, they protect files and resources from being misused. Next important short question is: 3. System security problem. System security problems are the risks or threats that can harm a computer system, steal data, or stop it from working properly. Security problems mainly happen because of viruses, hackers, weak passwords, or careless users. Some common problems: 1. Unauthorized access. Hackers break into systems to steal information. 2. Viruses and malware. Harmful programs that damage files or slow the system. 3. Data theft. Sensitive data, like bank info, is stolen. 4. Denial of service. DOS attackers overload a system, making it crash. 5. Insider threats. Employees misuse access rights. Example: imagine an online exam portal hacked during exams. Students can't log in, and question papers may leak. This is a security problem. Quick tip to remember: security problems is equal to hackers, viruses, leaks, overload. Good security practices like antivirus, firewalls, strong passwords, and user training protect systems. Next important short question is: 4. What is user authentication? User authentication is the process of verifying the identity of a user before giving them access to a computer system or network. It ensures that only the right person can use the system and protects data from unauthorized access. Authentication is done in different ways. 1. Passwords or PINs. The most common method, the user enters a secret word or number. 2. Biometrics, fingerprints, facial recognition, or iris scans. 3. Smart cards or tokens, physical devices to verify identity. 4. Two-factor authentication. 2FA combines password with OTP or fingerprint for extra security. Example: when you log into your Gmail account, you first enter your password and then confirm with an OTP. This is user authentication. Easy tip to remember. Authentication is equal to "Are you really you?" It acts like a security guard at a building, checking ID before letting you in. Next important short question is 5. What do you mean by computer security classification? Computer security classification. Computer security classification means dividing or grouping computer systems based on how well they protect data and resources. It helps in deciding what level of protection is needed for different types of information. The main levels are 1D. Minimal protection, no special security, anyone can access data. 2C. Discretionary protection, basic security, access is given by the owner, like setting file permissions. 3B. Mandatory protection, stronger security, system enforces strict rules and users are given labels like confidential or secret. 4A. Verified protection, the highest level, every action is strictly monitored and verified, used in military or top-secret systems. Example: your college computer lab may use C-level security, basic login passwords, while bank servers use A-level security to protect sensitive data. Easy tip to remember. Think of it like security levels in a building. D is equal to open park, C is equal to gated colony, B is equal to office with ID card, A is equal to military base. Next, Unit 4. Long questions. First important long question is: explain the principles of system protection in detail. Principles of system protection. System protection in an operating system means keeping the computer's hardware, software, and data safe from unauthorized access, errors, or misuse. The main goal is to ensure that only the right users and programs can access resources, and that no one can harm the system accidentally or intentionally. To achieve this, OS follows some key principles of system protection. 1. Least privilege. Every user or program should only get the minimum access needed to do their job. Example: a cashier in a bank's system can see customer balances but cannot approve big loans. 2. Separation of privileges. 2 or more checks should be used for important actions. Example: online banking may ask for both a password and an OTP to transfer large sums. 3. Fail-safe defaults. Access is denied by default, and only explicitly allowed permissions are given. Example: a new file in Windows is private to its creator unless shared. 4. Complete mediation. Every access request to files, memory, etc. should be checked by the system, not just the first time. Example: antivirus scans every file when opened, even if it was safe before. 5. Open design. System security should not depend on secrecy of the design but on strong authentication methods. Example: the Linux OS design is public, but it's secure due to strong passwords and permissions. 6. Least common mechanism. Shared resources between users should be minimized to avoid leaks. Example, private cloud storage for each user instead of one shared folder. 7. Psychological acceptability. Security measures should be easy for users to understand and use, so they follow them. Example, simple fingerprint unlock is better than typing a 20-character password every time. Easy way to remember. Think of a college campus. ID card checks at every gate, complete mediation. Only teachers can access staff rooms, least privilege. OTP-like approval for events, separation of privileges. Next important long question is: 2. Describe the access matrix and its implementation with examples. Access matrix and its implementation. In an operating system, many users and programs want to use resources like files, printers, and memory. To keep things secure and organized, the OS uses an access matrix. The access matrix is like a table that shows who can do what with each resource. Rows represent users or processes. Columns represent resources, files, devices, etc. Each cell contains the access rights: read, write, execute, etc. Example of access matrix. File A, File B, printer. User 1 read, write, read, use. User 2 read, write. User 3 read, use. This means user 1 can read, write file A and use the printer. User 2 can only read file A but write to file B. User 3 can't use file A but can read file B. This table makes it clear who can do what. Implementation of access matrix. Since a full table for large systems is too big to store, OS implements it in practical ways. 1. Access Control List (ACL). For each resource, store a list of who can access it. Example, file A, user 1 RW, user 2 R. Easy to check who can use a resource. Hard to check everything a user can access. 2. Capability list. For each user, store a list of resources they can access. Example, user 1, file A, RW, printer, use. Easy to check what a user can do. Hard to check who can use a resource. 3. Hybrid approach. Some systems mix both ACL and capability lists for efficiency. Easy way to remember. Think of the access matrix like a school timetable. Rows is equal to students. Columns is equal to subjects. Cell is equal to subject rights, attend, lab access, etc. The OS just decides who can enter which class and do what. Next important long question is: 3. Discuss various program threats and how to defend against them. Program threats and how to defend against them. In an operating system, a program threat is when a malicious program tries to harm your system, steal data, or misuse resources. Let's discuss common program threats and their defenses in simple terms. 1. Trojan horse. A Trojan horse looks like a useful program but secretly does harmful things. Example, a free game that secretly steals your passwords. Defense. Install trusted software only. Use antivirus and scan new software. 2. Trapdoor, backdoor. A trapdoor is a hidden entry into a program that allows hackers to bypass security. Example, a programmer leaves a secret login code. Defense. Regular code reviews and penetration testing. Apply software patches frequently. 3. Logic bomb. A logic bomb activates only when certain conditions are met. Example, a program deletes files on a specific date. Defense. Monitor unusual changes in code. Use intrusion detection systems. 4. Worm. A worm spreads itself across computers using networks, slowing down systems. Example, a worm that sends itself to all your email contacts. Defense. Keep systems updated. Use firewalls and block unknown network access. 5. Virus. A virus attaches itself to other programs or files and spreads when they run. Example, a virus that corrupts your documents. Defense. Use antivirus software. Avoid opening suspicious emails or files. 6. Trap injection. A hacker may inject malicious code into a trusted program. Defense. Validate input and use secure coding practices. Easy way to remember. Trojan horse fake friend. Trapdoor secret entry. Logic bomb timed attack. Worm self-spreading. Virus file infection. Summary. Program threats are like digital diseases for computers. To stay safe, always update software, use antivirus, install only trusted apps, and monitor systems regularly. Just like washing hands protects you from germs, cyber hygiene protects your computer. Next important long question is: 4. Explain cryptography and firewalling techniques used in OS security. Cryptography and firewalling techniques in OS security. Operating systems, OS, use cryptography and firewalls to keep data and networks safe from hackers. Think of cryptography as locking your data with a secret code and a firewall as a security guard that controls who enters or leaves your system. Cryptography. Cryptography is the process of converting plain data, readable text, into a secret code, ciphertext, so that only authorized users can read it. Encryption converts data into an unreadable format. Decryption converts the encrypted data back to its original form. Example, WhatsApp uses end-to-end encryption, meaning even WhatsApp cannot read your chats. Techniques. 1. Symmetric key encryption. One secret key is used for both encryption and decryption. Fast but sharing the key is risky. Example, AES, Advanced Encryption Standard. 2. Asymmetric key encryption. Uses two keys, a public key, shared, and a private key, kept secret. Example, digital signatures, online banking. 3. Hashing converts data into a fixed code to check integrity. Example, password storage in websites. Firewalling. A firewall acts as a security guard between your computer network and the outside world, internet. It checks all incoming and outgoing data and blocks anything suspicious. Types of firewalls. 1. Packet filtering firewall. Checks each data packet's address, only safe ones pass. 2. Proxy firewall. Works like a middleman between your computer and internet, hides your IP address. 3. Stateful firewall. Remembers active connections to improve security. Example, college Wi-Fi often has a firewall to block gaming or social media sites. Easy way to remember. Cryptography, like putting your diary in a secret language. Firewall, like a gatekeeper who checks visitors before letting them in. Summary. Cryptography protects data confidentiality and integrity, while firewalls protect networks by controlling access. Together, they make your OS secure, just like a lock on your door, cryptography, and a security guard at your gate, firewall. Next important long question is: 5. Write about language-based protection and capability-based systems with examples. Language-based protection and capability-based systems. In operating systems, protection is about making sure only the right person or program can access resources like files, memory, or devices. Two smart ways to do this are language-based protection and capability-based systems. 1. Language-based protection. This technique uses programming languages to build security directly into the software. The idea is to design programs in a way that they cannot access memory or files they are not allowed to. Many modern programming languages like Java or Rust have built-in safety features such as automatic memory management, no direct access to unsafe memory. Type checking, only correct data types can be used. Controlled object access, objects can be private or public. Example. In Java, if a program tries to read another program's memory, the Java Virtual Machine (JVM) will block it. This keeps your data safe. 2. Capability-based systems. A capability is like a digital key or ticket that gives a process permission to use a resource, file, printer, etc. Instead of asking "Who are you?" every time, the system just checks your capability key to see if you are allowed. Each process gets a list of keys, capabilities, and if you don't have the key, you can't access the resource. Example. Think of a hotel. Your room card capability opens only your room, not others. Similarly, in an OS, if your process has a capability for a file, it can access it, otherwise it's locked. Easy way to remember. Language-based protection, like designing a safe house where windows and doors are already fixed so no one can enter wrongly. Capability-based systems, like giving special keys to each person so they can only open their rooms. Summary. Language-based protection uses safe programming languages to avoid mistakes and block unauthorized actions. Capability-based systems use keys tokens to control resource access. Both methods make an OS safer, ensuring no one gets access they don't deserve.